Hello everybody, this is Mr. Combs, and we're going to start talking about the last unit for this semester. So we're almost done, one more unit, but this is a very important unit. You'll probably use the concepts that we talk about in this unit in a few of your math classes as you progress further after this semester. So let's talk about factoring polynomials. So before we talk about factoring, let's talk about a few definitions. First of all, let's talk about the word factor. So what does factor mean? So I'm talking about, in this case, factor as a noun. Okay, a factor is a number or expression that is multiplied. It's basically what a factor is. So let's say we had something like 5 times 3, and that equals 15. Well, we know that 15 is called the product. The product is the result of multiplication, but we can call 5 and 3 factors. And in fact, we can call them factors of 15. So 5 is a factor of 15, 3 is a factor of 15. But this also works with expressions, and we don't tend to think about, when we think about factors and product, we don't tend to think about expressions. But let's take the two expressions, x plus 5 and x minus 5. When we multiply those two together, we know from the things that we did last unit when we multiplied polynomials, we know that this is going to end up being x squared minus 25, because the middle terms will cancel out, because this is an x and a 5 with a plus and a minus in between them. And anytime you have that situation where you have the same two terms, but you have a plus between them in one expression and a minus between them in the other, we know that the middle terms are going to cancel, and we'll get what we call the difference of squares, or what we call a difference of squares. But in this case, the product then will be x squared minus 25, and the expression, the entire expression, x plus 5 is a factor, and the entire expression x minus 5 is a factor. Alright, so let's talk about using the word factor as a verb. So what if I wanted you to factor something? Now, to factor means to express as a product. So basically, if I took 15 and I expressed it as 5 times 3, what I've just done here is I've factored that. I've factored 15. And if I take x squared minus 25 and I express that as x plus 5, x minus 5, what I've done is I have factored. We have factored 15 into 5 and 3, and we have factored x squared minus 25 into x plus 5, x minus 5. Alright? Alright, let's look at a couple more expressions that we can factor. Let's look at some monomials. I can factor monomials pretty easily. Let's say I have 24x squared. I can factor that in several different ways. I can factor this as 6x and 4x, 12x squared and 2 times, times 2. I can factor it as 8x times 3x. I can factor it as 8 times 3 times x times x. There are several different ways. I mean, I could go on and factor 24 in several other ways as well. 24 times x squared, right? But when I get to an expression like x squared minus 25, I mean, we were able to factor it easily because we knew what from the previous example, what the multiplied form would be. But it's not as easy. It's not as easy to factor x squared minus 25. So what mathematicians have done is that they have come up with a list of ways that we can factor based on what our polynomial looks like. Okay? So we're going to call this the factoring list. All right, so on your information sheet for this week, I've actually given you a space where you can write the factoring list. So we're just going to keep that to the side. We're going to have a list of steps on the factoring list. And this is going to be sort of a list of steps that we go through when we're factoring any polynomial, okay? We're going to talk about the first two steps in this video, and then in other videos we'll add on. But what we're going to do basically is we're going to talk about the first step, and then you're going to look at step one, and step one you're going to complete, or you're going to go through for all polynomials. Okay, step two, step three, and so on, you will need to look at your polynomial, determine what it looks like, what its characteristics are, and then pick the step that you need to use based on what your polynomial looks like. It'll make more sense, I promise, when we start talking about it, when we start talking about each step. But for now, let's look at the basic thing. The thing that you're going to do when you see every polynomial and the directions are to factor, you're going to first try this. You're going to first try to factor out the greatest common factor. So factoring out the greatest common factor. All right, so let's take a look at some multiplication to sort of help us with this. Basically, if I have something like 5x and I want to multiply that by x minus 3, well, I know how to do that. That's not too bad. That was the last chapter. I'm going to say 5x times x, and I'm going to say 5x times 3. So 5x times x is 5 times 1 basically is 5, and x times x is x squared. And then 5 times 3 is 15. I'm going to put my minus, and 5 times 3 is 15, and there's no x to multiply the x by, so I just bring the x over. So the multiplied form is 5x squared minus 15x. All right, so let's say we had 5x squared minus 15x starting out. Basically what we're going to do is we're going to sort of use the distributive property in reverse. We use the distributive property to multiply 5x by everything in parentheses. Now we're going to sort of use it in reverse. What we're going to do is we're going to determine what the greatest common factor is, determine what is in common in 5x squared and 15x. We're going to write that greatest common factor down. In parentheses, we're going to list what we have left after we divide each of our terms by the greatest common factor. Okay? So I notice that in this case, 5 and 15 are both divisible by 5. They both have a factor of 5 in them, and that's the largest factor that they have number-wise. All right? Then I notice that they both have a factor of x. This one has 2 x's, or x squared. This one only has one factor of x. So I can only take the smallest amount of factors that I have out. So if I have an x cubed and an x squared, then I can take the x squared out because I have at least an x squared in the other term. So basically what you're going to do for your variables is you're going to look at the variable with the smallest exponent, and that's the one you're going to want to take out. So the variable with the smallest exponent here is x to the first, so I can take an x to the first out. Now in parentheses what I'm going to do is I'm going to list what is left after I divide each of these terms by 5x. So 5 divided by 5 is 1, and x squared divided by x is x. Now you can always check by multiplying. 5x times x is 5x squared, so that looks good. Alright, 15 divided by 5 is 3, and I'm going to have the negative here, the minus. And then x divided by x, that's just 1. That goes away. They cancel. They become 1, we can say. So really what I have is the expression 5x times x minus 3. This is the factored form. This is factoring. I've just factored that expression, 5x squared minus 15x. Let's actually write that down, basically, the method for factoring out the GCF. So I'm going to say factoring, let me get rid of this. Okay, factoring out the GCF. The first step is going to be to determine the GCF of all terms in your polynomial. Then you're going to write the GCF, and in parentheses we're going to write what's left when each term is divided by the GCF. Okay? So remember, in the factoring list, the first step will be factor out GCF. Okay? And then we're going to add the second term in this, the second step, I'm sorry, in this video. And the third and fourth and fifth and so on steps in the other videos. Alright, so that's it. Factoring out the GCF. Determine the GCF of all terms in the polynomial. Write the GCF, and in parentheses write, let me put a comma there, and in parentheses write what's left when each term is divided by the GCF. Alright, let's look at some examples. The first example I want to look at is 16 x squared minus 12x. Okay? Alright, so let's look at this. The first thing I want to do is I want to determine the numerical or the number part of the greatest common factor. So what number is 16 and 12 both divisible by? What number will go into evenly both 16 and 12? 4, right? So 4 is going to be the number part of my GCF. And then I have an x squared and an x. X is the smallest, so I can take an x out. So when I do that, in parentheses, I'm going to write what's left after I divide both of those terms by 4x. So 16 divided by 4 is 4, and x squared divided by x is x. Another way that I like to think about those variables is, instead of division, I like to think of this as I have two x's here, I took one out, so I'm left with 1. If I had 5 x's here and I took one out, I'd be left with 4, right? So that's a way you can think about those variables as well. All right, minus 12 divided by 4 is 3, and x, I had 1 x, took 1 x out, so I don't have any x's left. Here is the factored form. So if I ask you to factor 16x squared minus 12x, you would put 4x times 4x minus 3. There we go. That's it. Let's try another one. Let's try 15x cubed y squared minus, no, I'm sorry, plus 10 x squared y to the 4th. All right, let's look for the number that is in common in both 15 and 10, or in common to both 15 and 10. So 15 and 10 are both divisible by 5. So 5 is a factor of both of those. I think it's the largest factor. Let's see, the smallest x I have is x squared, and the smallest y I have is y squared. So my greatest common factor is 5x squared y squared. In parentheses, I'm going to write what's left after I divide both of those by the greatest common factor. So 15 divided by 5 is 3. X cubed divided by x squared is just x, or you can think of it as I had 3 x's, I took 2 out, so I'm left with 1. Alright, I had 2 y's, I took both of the y's out, so I don't have any y's left. Plus 10 divided by 5 is 2. And I had 2 x's, I took both of them out, so I don't have any x's left. But I had 4 y's, and I only took 2 out, so I'm left with 2 y's. Just a second, that's the phone. Okay, I'm back. I'm sorry, I had to grab the phone for a moment. That's factoring. Alright, let's look at another example. Let's look at negative 22 x to the 5th y to the 7th minus 14 x to the 3rd y to the 8th plus 18 x to the 6th y to the 4th. Alright, let's look at this one. If I'm looking at negative 22, negative 14, and 18, what number do all of those numbers have in common? Well, unfortunately, I wish it was I wish it were a bigger number, but it's not. I think it's just 2, right? So each of these is divisible by 2. What is the smallest x I have? The smallest x is x cubed, so I can take an x cubed out. And the smallest y I have is y to the 4th, so I can take a y to the 4th out. So in parentheses, I'm going to write what's left after I take and divide everything by 2x cubed y to the 4th. So 22 divided by 2, or negative 22 divided by 2 is negative 11. I had 5 x's, I took 3 out, so I'm left with 2 x's, or x squared. I had 7 y's, I took 4 out, so I'm left with 3 y's, or y cubed. Minus 14 divided by 2 is 7. I had 3 x's, I took them all out, so I don't have any x's. And I had 8 y's, and I took 4 out, so I have 4 left. So 7y to the 4th plus 18 divided by 2 is 9. I had 6 x's, I took 3 out, so I'm left with 3 x's, and I had 4 y's, I took them all out, so I'm left with no y's. Now, you want to check, and this is a good time to say this, you want to check to make sure that your numbers or your variables, you have not left anything in common. So if I had a number in common, or a factor in common, or if -11, -7, and 9 had a factor in common, then I wouldn't be done yet. I need to take some more things out. So that's the reason why you want to take out the greatest common factor. Alright, so here is the factored form. Now, one of the things I wanted to talk about with this one is that sometimes it's going to be helpful if we factor out a negative. Now, this is not something that you have to do all the time. It's just sometimes it will be helpful to us in completing our problems if we factor out a negative, okay? So when you factor out a negative, basically you're just going to factor out, instead of 2x cubed y to the fourth, you're going to factor negative 2x cubed y to the fourth, okay? Why might you do this? If you're asking yourself, well, why would I ever want to do that? It's because sometimes we don't want this first term, when we're factoring, we don't want that first term to be negative. We want it to be positive. So that's a reason why you might want to do that. Another time that you might want to do it is when we're looking at two expressions and we want two expressions to be equal, and they're not equal unless we take a negative out of one of those. That might be another time you would do it. But basically all this does is it changes the sign of everything in parentheses. And you can still do this with division. So if I have -22 divided by -2, now that's positive 11. And I have x squared y cubed. If I have a -14 divided by -2, now that's a positive 7. And I have y to the fourth. And if I have 18 divided by -2, that's a -9 x cubed. So if we wanted to factor out the negative, this would be our answer. So both of these answers are correct. Both of these would be accepted if you were putting these on a test or something like that. Negative 2x to the third y to the fourth, you can factor that out. And notice what it has done sign-wise is it's changed every sign. This was negative, now it's positive. This was negative, now it's positive. And this was positive, and now it's negative. Okay? So when we factored out the negative, it just changes the sign of everything in parentheses. Alright, let's look at one more example, and then I will let you try some. Let's look at 12x squared minus 3x plus 15. Alright, so in this one I'll notice that 12, 3 or -3, and 15, all of those are divisible by 3, right? So 3 is the number part of my greatest common factor. What's the smallest x? Well, here's the problem with looking for the smallest x. In this case, I have an x squared here, I have an x here, and I have no variables there. So because the x is not in all three of these, I can't actually factor out an x because the x has to be in all three. So if I took an x out, I would have an x left here. Okay, that's good. I'd have nothing here. That's okay. But here, I would not be able to factor an x out of here because there is no x. So in this case, I can only factor out a number. That's fine. Sometimes you'll only be able to factor out a variable. Sometimes you can factor out both. Sometimes you're only able to factor out a number. That's totally okay. So I'm going to still have parentheses. In parentheses, I'm just going to basically list what I would have after I divide everything by 3. 12 divided by 3 is 4x squared. 3 divided by 3 is 1, so I put minus. And then I'm not going to put the 1 there because I have an x, so I'm just going to put minus x. And plus 15 divided by 3 is 5. So 3 times 4x squared minus x plus 5 is the factored form. Okay, what I'd like to do now is give you a chance to try some. So I'll list a couple, and I'll give you some time to work through those and see if you can find the factored form. Basically, what you can do is just pause the video and you can have all the time that you like. So let's look at the following. 12x to the fifth minus 18x cubed minus 3x squared. And let's also look at x to the fifth plus 7x to the fourth y to the third minus 8x y to the fourth. Okay, I hope that you have paused the video and finished up. If you still need more time, pause now, because I'm going to look at the solutions of each of these. Okay? So let's look at 12x to the fifth minus 18x cubed minus 3x squared. Well, 12, 18, and 3, they all have a common numerical factor of 3. And x squared is the smallest exponent, so I can take an x squared out. Okay. Now, 12 divided by 3 is 4. I had 5 x's. I wanted to take 2 out, so I have 3 left. Minus 18 divided by 3 is 6. I had 3 x's. I took 2 out, so I'm left with 1. Minus, and 3 divided by 3 is 1. X squared divided by x squared is 1. So basically it's like everything cancels out, but remember when we're dividing, everything cancels to 1. So I need to put a 1 there. Sort of like a placeholder. And this is cool because, or these are cool because you can always check your work just by multiplying. So basically if I multiply 3x squared by 4x cubed, I should get 12x to the fifth, which I do. If I multiply 3x squared by negative 6x, I should get negative 18x to the third, which I do. And if I multiply 3x squared by negative 1, I should get negative 3x squared, which I do. So you can always check by multiplying. Okay? You can check factoring by multiplying. Alright, let's look at this next one. I have a x, or 1x to the fifth, or x to the fifth, plus 7x to the fourth y to the third, minus 8xy to the fourth. 1, 7, and 8, they don't have anything in common. So I can't get any numbers out of there, any numerical factors, number factors. They each have an x in them, but they only have the smallest x I have is just x. So I can take an x out. And there's a y in 2 of them, but not the other. So because y doesn't occur in all 3 of those, I can't get a y out. The only thing I can get out of here basically is just x. So in parentheses, I had 5 x's, I took 1 out, so I'm left with 4. I don't change the number at all. I had 4 x's, but I took 1 out, so I'm left with 3. And I have y to the third. Minus 8. I have an x, I took it out, so I'm just left with 8y to the fourth. And that's the full factored form. Let's take a look at this expression. 10x squared plus 5x plus 4x plus 2. Now, if I look at the factoring list, the first step says to factor out the GCF. So let's see what these things have in common. 10x squared plus 5x plus 4x plus 2. Well, I've got 10 and 4 and 2, but 5 doesn't have a common factor with those. I've got 10 and 5 that have a common factor of 5, but 5 is not a factor of 4 and 2. There's really none here, and if you'll notice the x's, they're not x's in all four. So basically I can't factor out the GCF. So that means it must be time for step 2. And step 2 you can only do when you have 4 terms. So step 2 on the factoring list, we're going to call that factoring by grouping. And you can only do factoring by grouping when you have 4 terms. Okay, so basically what we're going to do is when we see a factoring problem from now on, we're going to look if you can't factor out, or if you can factor out the greatest common factor, then you're going to do that. If you can't factor it out, then you're going to move on to step 2, and if you see 4 terms, then you're going to factor by grouping. If you don't see 4 terms, you have to move on. Alright, so let's look at the steps for factoring by grouping as we look at factoring 10x squared plus 5x plus 4x plus 2. And I know that 5x and 4x, those are like terms, and we could combine those if we wanted to, but let's not. Let's just leave it as 5x and 4x for the purposes of this example. I know that normally we would combine those together to make this as simple as possible, but alright, so the first step of factoring by grouping is to group the first 2 terms together and the last 2 terms together. That's why it's called factoring by grouping. Okay, so 10x squared plus 5x, we're going to group those together. And then plus 4x plus 2. We're going to group those together. Okay? The next step is to factor out the GCF in each group. Okay, so if I'm looking at the first group, 10x squared plus 5x, 10 and 5 have the common factor of 5, and x is the smallest variable, so I can take an x out. So this is going to be 5x times 10 divided by 5 is 2, And I had two x's, I took one out, so I'm left with 1, plus 5x divided by 5x is just 1. So 2x plus 1. Alright, in the second group, 4 and 2 have a common factor of 2. So when I divide 4x by 2, I get 2x. And when I divide 2 by 2, I get, oh, not 2. Sorry, let me erase that. I get 1. Now, do you notice anything amazing? You should notice something amazing. So what happens is the expressions in parentheses are the same. The expressions in parentheses are the same. We're going to factor those out. And write what's left. So in parentheses, those things are the same, so we're going to factor those out, and then we're going to write what's left. So 2x plus 1 and 2x plus 1, it's like now that's the common factor. We factor it out. After it's gone, we're going to write what's left. So what's left in the first grouping after it's gone is 5x. And what's left in the second grouping after 2x plus 1 is gone is 2, and it's a positive 2, so I'm going to write plus 2. And that is the factored form. I like factoring by grouping because it's kind of like a little trick. Alright, let's look at a few more. Let's look at this one right here. What if I have 3a squared plus ab squared minus 3ab minus b cubed? Alright, the first thing I'm going to do is I'm going to look to see if I have common factors. Okay? 3, 1, 3 and 1. There's no number that's in common to all of those. And I have a's and b's, but I don't have an a in every term. I don't have a b in every term. So there are no common factors. So it's time for step 2 on the factoring list. That's factoring by grouping. So the first thing I'm going to do is I'm going to group the first 2 terms together and the last 2 terms together. Okay? So I'm going to factor out common factors in each group. So in 3a squared plus ab squared, the common factor, I think, is an a. So I have 3a left over, because a times a is a squared, plus b squared. Alright, now in the second expression, the second group, negative 3ab minus b cubed. Now you'll notice that I have a positive 3a and a positive b squared, and I have 2 negatives in the second group. This might be a good time to use that technique of factoring out a negative. So I'm going to factor out a negative, and the factor that's in common is b. So I'm going to factor out a negative b. Okay, so remember, a negative 3 divided by a negative b, a negative and a negative, that's going to be a positive 3a. And then a negative b to the third divided by a negative b, that's going to be a positive. I had 3 b's, took one out, so I'm left with b squared. Now, do you notice anything amazing? I see something amazing. The expression in parentheses is the same, so I'm going to pull that out. 3a plus b squared. And in parentheses, I'm going to write what's left. A is what's left after I get rid of the common expression in that group, and negative B or minus B is what's left after I get rid of the common expression in the second group. So there's my full factored form. What do you think? Good. Let's try another one. Let's try x squared minus 3x minus 2x plus 6. Now this one again is another one where I have 3x and 2x that I could combine if I wanted to, but let's not combine them. Let's just use them the way they are in this for these purposes. All right, I notice that I don't have any common factors, so I can start to factor by grouping. I'm going to group the first two terms together. I'm going to group the last two terms together. Okay? The second two terms together. In the first group, I notice that I have an x that's in common. I had two x's in the first term. I took one of them out, so I have one left. And I have minus 3. Alright? Now, I have a 2 in common in the second. 6 and 2 are both divisible by 2. So I'm going to bring a 2 out, and I have negative x plus 3. You might be thinking to yourself, well, these are not exactly the same. This is x minus 3. This is negative x plus 3. What can I do to change the sign in that second parentheses? You're right. I can factor out a negative. So if I factor out a negative, what it's going to do is it's going to change each of these signs. So I can actually change this to a positive x and a negative 3. So again, how I did that was a negative 2 and a negative 2 is a positive 1, and a 6 divided by negative 2 is negative 3. So negative 3, or x minus 3, is what's in parentheses. X minus 3 is the common expression that's in parentheses. So I'm going to write that down, x minus 3. And in another set of parentheses, I'm going to write what you get after you get rid of that expression, and that is x. Let me make this set of parentheses better. X and negative 2 or minus 2. So x minus 3 and x minus 2, that's the factored form. What do you think? All right, let's look at a couple more, and then I'll give you a chance to try some. All right, so let's look at this one. What if I have 7x cubed plus 21x squared plus x plus 3? All right, so nothing in common in all four terms. So I'm going to group the first two terms together, and I'm going to group the last two terms together. So, let's see, 7x cubed plus 21x squared. Well, an x squared's in both of those, I notice. And 7 and 21 are both divisible by 7. So 7x squared is the greatest common factor in those two. And then I have an x plus 3 left over. Alright, I notice that in the second grouping, I don't have any common factors, but I do notice that what is already there is a match for what's in parentheses in the first grouping. So when that happens, the trick we're going to use is to factor out a 1. So I can take 1, and x divided by 1 is x, and 3 divided by 1 is 3. See, when you divide by 1, it doesn't change anything. So we can factor out a 1, because we need to have a number here, right? Now I have two expressions with the same, or two parentheses with the same expression, excuse me. So I'm going to bring that out, x plus 3. And I'm going to write what's left after I get rid of that expression. So it's 7x squared plus 1. There's my factored form. All right, so let's look at one last one together, and then I'll let you try some. What if I have 4 p cubed plus 4p squared minus 12p plus 40? What's the first thing I should do? The first thing I should do is I should look for common factors. And if I notice 4, 4, 12, and 40 all have a common factor of 4. So the first thing I'm going to do is I'm going to pull a common factor out of the entire group. So that'll leave me with p cubed plus p squared minus 3p plus 10. Right? All right. So now, let's see. What do I have in common? Well, let me take a look at this. Now I see that I have 4 terms in parentheses. 1, 2, 3, 4. So we can continue to factor until you have expressions that are not factorable. So I'm going to look at what's in parentheses, and I have 4 terms, so I need to factor by grouping. So I have p to the third plus p squared. There's a p squared in that. Now I'm just going to have p plus 1 left over. There's not really anything in common, 3p plus 10, and p plus 1 doesn't look like 3p plus 10. So basically, I'm going to have to conclude that this one doesn't factor any further. So basically, 4 times p3 plus p squared minus 3p plus 10, that's all that it factors. Okay, well that's not what I wanted. So let's take a look at another one. But that happens sometimes, so I'm glad we did that one. But that's not what I wanted. I wanted to look at something else. So let's look at another one. All right, let's look at this last one together. So what if I have 2y cubed plus 16y squared minus 4y minus 32? Okay, so the first thing I'm going to do is I'm going to look for common factors. According to the factoring list, that's the first thing. 2, 16, 4, and 32 all have a common factor of 2. So I can take a 2 out. And what I'll have left over is y cubed plus 8y squared minus 2y minus 32 divided by 2 is 16. Now I notice that I have 4 terms in parentheses, so let's try factoring by grouping with the 4 terms that I have in parentheses. So I'm going to group the first 2 terms together, and I'm going to group the last 2 terms together. Okay? So I have y cubed plus 8y squared. I think I have a y squared in common there. So that's going to leave me with y plus 8 left over. Here I'm going to factor out a negative along with my number because both of those are negative. I need to make them both positive, so this is a good time to use that trick. And there's a factor of 2 that's in 2 and 16. So I'm going to have positive y plus 8. Y plus 8, they're the same. And y squared minus 2 is what's left after I get rid of y plus 8. Now, because I factored a 2 out at the beginning, I have to remember to bring that 2 down. Can't forget about my little buddy 2. So I bring that 2 down, and this becomes the full factored form. All right, now let me let you try some then. So I'll put some on here, and then you can try those. First of all, let's look at x cubed plus 7x squared plus 2x plus 14. Let's look at 3x squared plus xy minus 12x minus 4y. Let's look at 5ab plus 10a plus b plus 2. And last, let's look at 5x cubed plus 15x squared plus 20x plus 60. So go ahead and push pause and work through those, and then we'll look at the solutions together in just a little bit. Okay, I hope that you pushed pause and you worked on these a little bit on your own. But for now, let's take a look at those together. Let's look at the first one. There's nothing in common to all four, so I'm going to group the first two terms together and the last two terms together. In the first two terms, I see that an x squared is what's in common. So I'm going to have an x, because x times x squared is x cubed, plus 7 left over. In the second two terms, I see a 2 is what's in common. So I'm going to have an x plus 7 left over. That's what I want. X plus 7 is the same. So I'm going to factor it out. Right, what's left? I have an x squared. This is a positive 2, so an x squared plus 2. That's the full factored form. All right, let's look at the next one. There's nothing in common to all four of the terms, so I'm going to try factoring by grouping. In this case, there's an x in common in the first group, so I'm going to be left with 3x plus y. And I see a factor of 4 in common, but I also notice both of these are negative, so that maybe means I want to use my trick of factoring out a negative, and I think I do, because these two, the 3x and the y in the first set of parentheses is positive, or are positive. Alright, so I'm going to take a factor of negative 4 out, so that will leave 3x plus y. 3x plus y and 3x plus y is the same. So I'm going to write that down. After I get rid of it, I have an x and a minus or negative 4. So that's the full factored form. Alright, let's look at this next one. Nothing in common to all four, so let's group the first two terms together and the last two terms together. A factor of 5 is in common, 5a, is in common in the first two terms, so I have b plus 2 left over. And there's nothing in common in the second grouping, but I notice that b plus 2 looks the same as the first set of parentheses, so I'm going to just factor out a 1, and 1 divided by b, or b divided by 1 is b, and 2 divided by 1 is 2. So that means that b plus 2 is my expression in parentheses, and 5a plus 1 is the other expression, and that's my full factored form. All right, in this last case, let's take a look. What is in common, if anything? 5, 15, 20, and 60, they all have a common factor of 5. So I'm going to take a factor of 5 out. So I'm going to have x cubed plus 3x squared left over, plus 20 divided by 5 is 4x, plus 12. 60 divided by 5 is 12. All right. Now I notice that I have 4 terms, so I'm going to try to factor by grouping. Group the first 2 terms together and the last 2 terms. There's an x squared in common in the first 2 terms, so I'm going to have x plus 3 left over. There's a 4 in common in the last 2 terms, so I'm going to have x plus 3 left over. X plus 3 is the expression in parentheses that's common, and then I'm going to have x squared plus 4 left. And I can't forget about my 5. So that is the full factored form. Alright, I hope this video has helped.